and let's begin. All right. So, can all of you guys see my screen?
Yep,
Perfect.
you got yes.
Okay. So, hey everyone, I hope you all are having a fantastic day. Now, before we get things rolling, I just wanted to let you know that we're going to be having a quick Q&A near the end of this workshop, so if you guys have any questions at all, feel free to drop them in the chat. Now, if you don't know me, my name is Aditya Dewan, and I'm a 15-year-old here at the Knowledge Society. Now, I've always been a really curious person, and over the last year, this curiosity has led me down a long and ambitious path. The first stop on this path was that of AI. Honestly, I think it's insanely cool how we can take a computer and get it to think like a human. But I thought it'd be even cooler if we could apply that to cars. So that's exactly what I set out to do: build a self-driving car inside a simulator around a fixed track. On the screen is a working demo of this AI as it tries to drive itself 5 laps around the fixed track. And honestly, I learned a lot from this project, both about AI and how to learn and break down complex topics. Now, at TKS, we have something called challenges. And basically, these are 4 week-long consulting marathons where you and your team have to solve a problem given to you by a certain company. This year, we were super fortunate to have worked with the United Nations with a very special case: improving female digital literacy around the world. Together, me and my teammates Kevin, Gibran, and Anuraj decided to further dissect Rwanda, a country located in Central Africa. And what we found was quite surprising. The government had invested hundreds of millions of dollars into improving digital literacy. But regardless, it had only improved by 3% in the last 5 years. What was the catch? We realized that the real problem wasn't the infrastructure, but rather the teachers. See, 80% of Rwanda's population is actually rural, but the government was only focusing and investing on urban programs. So, to fix this, me and my teammates unveiled a 3 phase solution called Rural Connect, establishing a rural recruitment program to deal with teacher shortage, a 1 month training program for technology, and establishing teams to create positive school cultures. Ultimately, we predicted that this would improve quality of life for over 3,700 citizens and increase digital literacy for 1,700. As of now, our recommendation deck was chosen from TKS Global and is currently being reviewed by the UN. And honestly, it was a phenomenal experience that helped me 10x both my leadership and problem solving skills. Overall, if my experiences in the last year delving into AI, improving digital literacy, and solving the nuclear crisis have taught me anything, it's this: there are a lot of problems in this world that need solving. And lately, one of these problems for me was that of healthcare. I'm sure you all know the state of our healthcare system. Especially with COVID-19, it has been struggling really badly. We have overfilled hospitals, extremely high waiting times, and stressed medical staff, which provide a detrimental experience to the patient trying to get medical care. And unfortunately, patients who would be willing to get a checkup beforehand have just stopped going to hospitals because they're afraid of getting sick. Even if their symptoms are severe, they'd rather stay home than go to a doctor and take a risk. This is a huge problem. We have places in the world where people die from not having access to healthcare in the first place. And yet, here, people choose not to go, even though we're fortunate enough to have those tools. And honestly, that is insane. Today, we can get products delivered to our doorstep, talk to one another through a screen of pixels, and order food in minutes. If we have online shopping and calls, why not online healthcare? Why not receive a diagnosis without having to go to the doctor in the first place? And upon discovering this, that's exactly what I set out to do: to build a web app that could take in your symptoms and actually give them a reliable and accurate diagnosis. But as you can probably tell, there's a slight problem with this. How? Well, this is where AI, or artificial intelligence, comes into play. And trust me, it's not nearly as complicated as you guys might think. We're surrounded by these algorithms everywhere, recommending cat videos on Instagram, filtering your email for spam, and even renting taxis in extreme cases. If you're alive, there's a pretty good chance that you've been exposed to an AI algorithm at some point. And basically, AI is just a field of computer science that tries to get machines to think like humans. It's difficult to do, but it manages to do this with a bunch of algorithms, letting it learn from its previous mistakes. Cool, right? And if you're confused, here's a quick example. Let's say that you wanted to get an AI to tell the difference between a cat and a dog. Now, us being humans, we can do this pretty easily. But in this case, our AI just completely fails. Right now, it's like a student who hasn't really been taught much of anything. It basically has no clue what's a cat and what's a dog. But as we give it a teacher, it starts to learn. Our teacher presents different images of cats and dogs, thousands and thousands and thousands, and tells it that, okay, this is a cat and this one is a dog. Over time, our AI slowly starts to get the difference until one day it realizes that, hey, cats tend to have whiskers and dogs tend to have drooped ears. Now we have a bot that can actually tell the difference between a cat and a dog, even for pictures that it's never seen before. But wait, how on earth is it actually doing all of this? Well, it's actually pretty simple. AI is built off of small units called perceptrons. And what these do is that they take some input and give you an output, like a very simple function. For example, I might give it a 5, and it would transform that number in some way, maybe multiplying it by a 10, and output me a 50. And an AI is really just made of thousands and thousands of these tiny building blocks, like a giant mega function. But it would be a little messy if we had a bunch of perceptrons just flying around. So instead, they're organized into layers of perceptrons, ultimately forming something called a neural network. In this case, you input some value into the input layer, the input gets transformed through the hidden layers, and finally gives you your desired output from the output layer. And you don't just have to input numbers. We can use some clever tricks to put in both pictures and words too. Now, for our symptom diagnosis bot, the user is going to be inputting 4 of their symptoms. So we need a way to convert their symptoms into numbers. And I did this via encoding. Basically, I took each symptom and converted it into a number. For example, a cough would be 1, stomachache 2, and for example, if the patient wanted to leave a symptom blank or only had 2 or 3 symptoms instead of the 4, we could simply turn that into a 0, represented by nan, or not a number. Now that we've converted our data into numbers, we have one happy bot. All right, I've been talking a lot over the last couple of minutes, so you know what? Let's play a quick game. Basically, under one of these colored squares is a picture of an apple, and all you guys have to do is guess under which square the apple is under. So just feel free to yell out whichever color you guys want to guess.
Red.
Red? Nope, that's a pineapple.
Orange?
Nope, come on guys, you can do better.
Green.
Blue.
Pink.
So I think someone said blue. Whoever that was, you're absolutely right. The apple was underneath blue. Now let's try a second round.
White.
Nope, pineapple.
Blue.
Oh, I did, yeah.
Whoever said blue, good job. It was apple again. Congratulations. Let's try that 2 more times and see if you guys can notice a pattern.
Blue.
Blue.
Perfect. And last one.
Blue.
Perfect. Now, if you guys noticed something, it was probably this. The apple was always underneath the blue square. And believe it or not, you guys just did exactly what an AI does. You performed a task, you got it wrong, and then used that data to make your prediction better and better until it was pretty much perfect. Now, let's get out of the world of theory and actually build this thing. Now, can you guys see my screen, like the IDE?
Yep.
Yes.
Perfect. Now, over here, we have our coding environment. And if it looks a little bit intimidating, don't be. It's actually pretty simple. All we're going to be doing is that we're going to build the model that we talked about in the presentation section and to see if it actually works. So if you guys recall, we mentioned that the user will input 4 of their symptoms. So in this case, we're going to specify a variable called input shape to be 4. And this is just representing the amount of symptoms that the user will input. Next, we're going to define our model as a Keras sequential model. Now, a sequential model is just what we were talking about, a neural network with an input layer, hidden layers, and output layers. Now, let's go on to the meat of our code, which is the actual layers themselves. You kind of need layers for a neural network, which is made up of layers to work in the first place. So we're just simply going to add one dense layer, and a dense layer is just a layer of perceptrons as we were talking about before. And here, we're going to specify its input shape as the variable that we previously described. So in this case, input shape would be equal to the variable, which is input shape. Now, for the sake of time, I'm just going to copy paste the rest of our layers of our model into the code. And as you can see here, we simply have a bunch of layers combined together. Now, you might notice something interesting. What are all these numbers about? There's 25, 1,600, 200. This is simply the size of the layer in the first place, the number of perceptrons that we have in a given neural network. And honestly, these values are pretty arbitrary. But usually the more perceptrons you have, or the higher the number you have, the more accurate your network becomes. Though this comes at the expense of training time, which is the amount of time it takes for a neural network to learn the information in the first place. And second, we have these things called activation functions. These are simply value compressors. Now, if you guys don't know this already, neural networks are kind of crazy when it comes to outputting values. They might output a 6, a negative 0.5, 387. And if you're trying to predict something, that's probably not helpful. So all these activation functions do is that they squish all of those values in a certain range. For example, the sigmoid function converts all these random values between the ranges of 0 and 1. And here, the ReLU activation function takes all the negative random values that our network might output and converts that to 0 and makes all the positive values the same as they already were. So now, let's compile this model and see what we get. So as you can see here, our model is pretty big, almost 1 million parameters. Though in the context of neural networks, this is actually pretty small, surprisingly. So now let's train it. And as you guys can probably see, over time, our model should become more and more accurate, which will be represented by a metric called accuracy. Now, first, our model starts off with an accuracy of 17%. But as time goes on, we see 24, 37, 43, back to 40, 56, 53, and ending off at an amazing 64% accuracy, when compared with doctors who have an accuracy of roughly 20 to 50%. So in basically 10 seconds of training, we have achieved an accuracy of 64%, with the AI learning from its mistakes and improving over time. Now, 64% is cool and all, but in a healthcare scenario, you kind of don't want your accuracy to be 64%, because obviously you're dealing with actual lives here. That's why the actual app that I deployed using Heroku and Flask has an accuracy of above 95%, which is quite frankly just insane. Now here, it's pretty simple. All we need to do is input the symptoms that we might have and then receive a diagnosis. So the two symptoms that I'm going to be inputting right now are that of cough and stomach pain. These are pretty common symptoms individually, but when you combine them, they are usually indicative of a disease called tuberculosis. So let's see if our AI can actually get that right. And in case it doesn't, we should always remember the fact that AIs suffer from something called a loss of accuracy. Basically, as you give an AI more and more random scenarios to train, its accuracy actually starts to decrease as time goes on. So because of this, we need to take care of this problem and solve it via something called one-hot encoding. Basically, we'll take all of our values and turn them into some representation of a number so that our AI always sees the same numbers again and again and can make predictions based off that. Now, as you guys notice in our web app here, it is pretty slow. And the reason for this is that of scale. As you can probably tell with our 1 million parameters given in the AI bots, the problem is that running this on a server somewhere is very, very computationally expensive. Basically, the more data you have, the longer your AI is going to take to train. And that's something that we can definitely see with the web app here, which is deployed using a simple web app called Heroku. Now, given this problem with scale, that represents one of the main challenges of AI moving on into the 21st century. How do we deliver AI products to consumers fast, efficiently, and most importantly, accurately? And in order to prove that, we need to make sure that our models are both small, fast, and actually can provide reliable and accurate predictions on a daily basis. Now, as you can see here, our model finally decides to predict, and we actually received the right prediction in this case, which is tuberculosis, along with the quick warning that, hey, this is just an AI that's giving you a diagnosis. You should probably get a professional opinion first. Now, ultimately, I feel like this truly presents the enormous potential of this technology. Potential that can truly help us solve the world's greatest problems, and for me, help me on my journey to make the world a better place for us all. And ultimately, it's not just me who's doing this. Today, we have one of my good friends, Kevin, who's also on this journey to solve the world's biggest problems with AI. And he's been doing something similar as well, except he's working more in the intersection between AI and mental health. So, Kevin, do you want to talk about your project?
Absolutely, for sure. Thank you so much, Adi, for that amazing presentation. And it just like shows you the power and potential of this new emerging field of innovation. And to kick it off right now, I actually will just kick it off with a really, really quick introduction as well, and get my screen share going as well at the same time. But on a higher note, so at the highest level, my name is Kevin, and I'm currently a 16-year-old innovator as well here at the Knowledge Society, focused on the intersections between artificial intelligence within business, healthcare, and education. And you see, over the past 10 months, my experience at TKS has been absolutely amazing, because you see, the power that we've been able to have directly within all the different resources, the community, and all the different elements of part of the journey has been absolutely amazing. I will make sure that I get this directly with you. And there we go.
Kevin's been working on some really sick projects in the last couple of months. And at least from my experience, it's been insane how a bunch of 15-year-olds can come together, make an AI algorithm that can solve a problem. And I think Kevin can agree with the sentiment too. It's just amazing. It's an amazing feeling.
Absolutely. I'll give you back host so that you can admit anyone that comes in at a later time. Cool. Perfect. Cool. So like I was saying, I truly learned the power that artificial intelligence can play as part of our daily life as part of my focus that I did. And to get myself immersed first in AI, I actually went through a bunch of courses, resources like any other person would when they're first immersing themselves into the field. And to be honest, there's a ton of information and resources. We live in an age where there are abundant amounts of information and resources to get started in any sort of subject that you want to learn about. But like many others have said time and time again, I actually experienced the most growth when I invested in project-based learning. And this actually came when I did something like the common image classification MNIST model, or even the breast cancer detection model that I did a while back. And I've been feeling super blessed when our amazing TKS directors actually announced the Instacart Consulting Challenge, where we were also asked to design a recommendation to their engineering team on how they could systematically improve their customer experience, where I learned a ton of skill within project management, slide creation, and also time management, and also solving really important problems by interviewing people and getting different perspectives. Then many months later, I partnered with my good friend Aditya, Jibby, and Anuraj to work together on our United Nations project to try and create Rural Connect for a proposal to bridge digital literacy gap for over 3,700 Rwandans and directly improve their education system through a systematically designed pitch deck. See, those three core buckets are only touching the sort of core surface of all the amazing, cool, fun stuff that we've gotten up to. But throughout these experiences this year, I've actually learned that there's one commonality within all of these different areas. It's that there are so many problems that need to be solved, not just abroad, but even here in North America, and more specifically, Canada. See, one problem that actually touched really close to my own heart was mental health. During the pandemic, like many of you, my mental being definitely took a huge toll and hit towards and actually ended up affecting my overall productivity and ability to work on things that I deeply care about. Because within the ability that I had amazing resources and amazing people around my side, I still had internal demons that I was fighting through. I ended up constantly feeling anxious, down, and socially isolated. And like many of you, I think it's really hard to actually take yourself out of that situation and get the help that you need. But as someone that doesn't like giving up, I thought I would actually just get up and reach out for help. I wasn't going to let this continue. So I started to go online and research like any other person would on what the options were, right? And eventually I found that the support networks and groups do exist, and there are a lot of different community associations along with different things like Kids Help Phone and whatnot. But to actually get long-term support and actually get in touch with, for example, a therapist or psychologist or whatnot, it is actually extremely difficult. There's a few core problems, right? It's like extremely hard to find these resources. They're often buried deep into some websites that are really hard to navigate that look like it came from 1999, or there are also like huge wait lists to actually seek the help. And then in some cases, you actually also worry about whether your health insurance or OHIP or your health plan is going to cover the cost, since obviously any treatment outside of the typical forms are usually pricey. And then also there's like the fear of reaching out or even the stigma, right? And I wasn't alone, because in a study conducted by the WHO a few years ago, they found that 30 to 80% of those struggling with mental health don't actually get the support that they need. If you think about it, like on a scale of 970 million people suffering worldwide from some form of mental health concern, that's 291 to 776 million people that are suffering alone, right? And the true number could be much, much higher, simply because A, you have the pandemic, which has extremely exacerbated the issue, and then also B, those are self-reported numbers, which, for example, the people that don't actually get the help, there's no way of actually accounting for these people, right? And that's why I decided to leverage the power of artificial intelligence to create a demo or a mini project surrounding a mental health chatbot for awareness, diagnosis, and general advice named Aura. In the interest of time, I'll actually quickly walk through the model and then provide a quick demo at the end. So I will actually get this directly to you. Can you see this as well?
No, we can't see it.
Okay, there you go. Cool. Perfect. Amazing. Can you take a look at this now? This is good.
Not yet.
There you go. Yep.
Yep, we're good.
Perfect, yeah. So essentially, like Adi was mentioning, VS Code is an absolutely brilliant IDE that's used by many people in the sort of industry, and it's very much adored by many people. And essentially, the core functionality of this sort of chatbot is actually to take an input, reference a sort of corpus of knowledge, and then directly output sort of an answer based on that. So as a result, I've created sort of a few core files, essentially app.py, chat.py, the model.py, utils.py, and then also a really quick train.py. So essentially, I've wrote the code essentially to break it down really simply. So at the highest level, this is the neural network that is used that actually powers everything using PyTorch. Then beyond that, this is where you actually see everything getting trained as a higher level. So importing all the libraries, essentially Python libraries and also machine learning libraries as well. And then bringing that all together, trying to create functions and also different variables to actually store all of the input that the user would enter. And then as a result, input that into the model and then allow for the actual model to output an answer that correlates with the corpus of knowledge that we've created. So at the highest level, to actually give you a really quick demo of what this actually looks like, I'm going to hit run. And then as you can see, it should actually really quickly show up directly with that. And then allowing for this, I'll move the screen over here. And essentially this is a really quick graphical interface that actually shows up. And then what you can do is like, be like, hey, and then our reply is, hey, I'm doing well. My name's Ara, what can I do for you, right? And then I'd be like, okay, well, what do you do? Okay, and they're like, okay, I love that question. My name's Ara, mental health friend, trained to support you through any issues, but then also sort of giving information on any issues that you might want to ask about, right? And then beyond that, you can also sort of ask, okay, hey, I want to learn more about anxiety because I'm curious, right? And sort of gives like a really quick answer, right? Or say, for example, I want to really quickly brush upon the idea of depression, or interesting, okay? Tell me about depression then, right? And then this is also inputs another quick response around depression. Obviously, there's a long way to go in terms of actually deploying this into the actual world, whether that be through different web apps or whether that be through Roku or different other sort of platforms like Vercel. But in any case, this is the power of actually having this resource there and actually being able to link up to a bunch of different sources in the future. For example, even referencing different other resources that you can provide, or even any support groups or any associations that you can sort of also provide the end user would be absolutely super powerful. And retrospectively, I think being able to have this when I was sort of going through different periods of my life was actually been super duper helpful. So that's basically it. And at the end of the day, that way that I like to think about things is that if we don't actually solve the problems today, then we won't have that better future tomorrow. So let's go and create the better future tomorrow. Thank you.
Absolutely. So if you guys have any questions, feel free to tell us.
How does Aura actually give you the answer?
Yeah, great question. So essentially, like I mentioned, I can actually share my screen and actually prop right back to that. But essentially, what I've done, this is a really quick sort of, it's been programmed to the extent where it actually allows for referencing to a corpus of knowledge. So essentially using intents.json, I've sort of created a sort of list of general responses and then allowed the machine learning model to derive from that. So for example, I've sort of created intents and then using sort of JSON and normal JavaScript and trying to create actually a file that actually references, for example, tagging it as a greeting. So that actually gives it a category. And then patterns would actually be, for example, whatever they enter or any situations or any scenarios or any references to different forms that they may say hi, right? And then, for example, in a response would actually pick directly from referencing the context that they sort of gave and then trying to create picking one of the three answers that makes the most sense for that end user. So that's essentially the highest level. And then in terms of how the model actually works and goes through everything, if you can take a look here. So this is actually the sort of chat.py file, which actually brings together all of the different elements. So this imports the libraries and then also brings together all of the different models that I've created in the other sort of files, and then actually links that up to the graphical interface, and then also allows for the user to put in a response and then allows for that model to translate and then prompt out the actual final answer. So yeah, I hope that answered the question.
So I have a related question to that, if I could. In the example that you've shown here, more or less, the AI is trying to put out a single answer. Would you have an option where basically it's an additional nest and it's the AI is then looking for further input? I guess the example I'd like to use there is, when I go to Amazon, let's say, I would like information on kitchen appliances, and then I would like to be given options of what kind of kitchen appliances, those with water in them, those with electricity that go to them, those kinds of things.
For sure, yeah. That's definitely something that I'm actually working on building out for the next coming days as well. I think that this is something that I've been doing the last 2 weeks or so. And it's been super cool as a learning experience because previous to that I had no knowledge, but specifically the first sort of metric or prototype that I was trying to build out is essentially at the highest level trying to give a single answer response, and then also then creating that sort of conversational AI that we one day would want to also achieve, and then also linking that to different things like GPT-3, right? For example, sort of Elon Musk's pet project as well in the realm of AI, and also trying to create that sort of more seamless experience that can allow for more free-flowing conversation, much like real life. Yeah.
That's great. Very well done.
Thanks. Get it.
So I was just wondering, so collecting training data is a important part of training a model. I was wondering what sources did you use to get training data, because it's pretty interesting stuff.
Yeah. So essentially, what was interesting is that, so in the realm of mental health and psychology, there's actually this thing of DSM-5, and I sort of end up taking a look, just for my own curious interest, just taking a look and diving into that huge reference manual. And then sort of I took the most relevant parts and then also just ended up just building it out myself, simply because I think as well, for my purpose and the use case that I wanted to apply it in, there wasn't really many other data sets available. So then I just gathered and congregated all the best resources, the official guides on the different sort of mental illnesses or disorders or any other problems that exist in the space, and then also put it together into that one JSON file. But yeah, it's definitely something that's evolving and I'm trying to build out further even.
Yeah, so for Kevin, yes, as Kevin was mentioning, so for his project, he used that kind of library. For my one, what I actually found was that there are very minimal data sets that actually have a user's input of symptoms and diseases, right? So what I did is that I collected a lot of this data myself, going through medical records and checking things out. So it definitely was very time consuming. And I also found some hints of a data set on Kaggle, and I extracted some things from those. So what I'm hoping to do, however, is that the problem with this is that if you input your symptoms and you get a disease, it's not individualized to the person, right? If you have a certain medical history, there might be more likelihood of certain diseases as opposed to others. So one thing that I'm working on is putting a probability distribution, how likely would it be that you have this disease as opposed to this one?
Very good.
So I have a question. What direction do you want to take with this project? What's your overall goal?
Yeah, I guess Addy can sort of speak to that first. Go ahead.
Yeah, so for me, at least, I think the primary goal of projects like these ones is to prove the potential of this technology, right? Obviously AI is relatively new, Like it's only really gained steam in the last 5, 7 years. And honestly, when I think people create these kinds of projects, not only are you proving that, hey, this exists, we can solve this problem with a guy sitting inside his room coding for like 12 hours straight, but you're also showing the fact that, hey, we have an entire group of people on this planet who are able to do these things individually, right? And then the question is, what can you do when you get a lot of these people, put them together, and try to truly change the world? And I honestly think that the limits there are just non-existent. And I think that's really what we were trying to prove with this project, is that it's possible, and that with enough talented people learning good things, we can truly make an impact.
Absolutely. That's a fantastic answer. And I completely agree with you, like on all counts. I think even beyond that, like the sort of personal conception that I had in mind, or like the intention going into the project, was that, hey, let's learn a new skill and let's be able to actually develop the competence to be able to build like something similar in the future. And then also B, I think it was actually just like a testament to the power and just like trying to test out like what someone 16-year-olds can do in their own bedroom and chilling for maybe like a week or so even, and just like coding repeatedly. I think that the promise with that is insane. And if you like actually bring in professionals and you bring in like a team of like consulting doctors and whatnot, I have an amazing friend, I don't know if he's here in the audience today, but he's actually building out like a similar sort of mental health solution for specifically on a larger scale that's actually being tested by clinical doctors and whatnot, and also bringing in a whole cohesive platform, which is absolutely crazy and insane. And he's also raised like I think it was like $50,000 in startup funding, which startup funds, which is absolutely amazing. So the promise and the potential is definitely there. In terms of like how I want to take this in the future, I think I definitely want to try to keep building this out, keep refining my own skills, and then see if I can actually like ship this out in the next like 2-3 weeks, and then also see if I can actually get some beta users and try to see how they like it and whatnot, and then also bring on like a consulting team of like doctors and ask for their opinion as well. I think that's the same with Addy, right? Like trying to take this further as best we can.
Yeah.
So along the same lines, what would you say has been your biggest challenge setting this up, even to this point, let alone, I guess, weaknesses in the process going forward?
I think you guys saw this like while I was in the demo as well. I think the biggest problem is going to be scale, and that's one thing that I had trouble with as well, right? As you probably know, there is a big difference between an ML model working in an isolated environment on your laptop and actually put out there into the real world with random test cases. And especially with the delay between someone inputting their symptoms, getting that diagnosis, that I think is one of the core challenges that we're working towards solving in the next coming weeks. And as for the main challenge that we were facing, but we managed to overcome, I think the main one there is getting the AI to actually understand the data, right? Because obviously trying to find trends in a data is like trying to find a needle in a haystack, and you need to have the right set of magnets to actually extract it and actually enable real world usage of it. So I think that we tested for my project, I was testing for like a good 3-4 weeks at least, trying to get like trying different models, different variations, different input sizes, and I finally found a variation that works properly. So I feel like that initial roadblock to finding that right combination of input neurons, output neurons is the main obstacle.
Absolutely, that's a great answer as well. I think for me specifically on my project, I think the biggest obstacle was actually translating all the theory and the things that I've learned through different courses and whatnot, and actually applying it to like an actual real world like use case, and actually building out the problem, a sort of solution and model from like the ground up. I think along the way I consulted heavily like a few other, so a lot of it's like also Googling. I know, like for example, there's this common joke in the programming sort of community that if you're not Googling as you go, it's sort of unheard of. But I think definitely learning as I go. There was a lot of things that I picked up, sort of different libraries that I learned. I went through like data camp courses on natural language processing at the same time. There was like a few YouTube sort of like rabbit holes that I went under and tried to heavily reference, for example, some of the other huge YouTubers that have done something similar, or like even like huge programmers in the space as well. Sort of got their input on like different parts of the project. I think then actually the biggest challenge seeming into that was actually like congregating all the data and trying to actually like clean it up and then also make it really applicable for this use case and sort of this thing that I wanted to build out. So I think that those two sort of buckets was actually the sort of the biggest roadblocks and challenges. But I think like beforehand, there's a lot more. But on the highest level, I think once you actually hit that button, run, and it actually works, like, I think that's like the biggest feeling of satisfaction and joy. So yeah, that's that.
how many input questions and answers were like necessary to train your model to be like the best it could be?
Yeah, so I think on my end, I know like I can Adi is like also answer on his end, but for me, I actually congregated sort of a size of like maybe 50 sort of nested sort of boxes and tags, and then also I like ended up like creating responses for like 100 or so sort of like questions and answers respectively, and then that sort of allowed it to have like a pretty adequate sort of backing. For example, like the idea that people could end up like saying the same thing very differently, for example, right? I think like the next step beyond that would be trying to get the model to be unsupervised, to be able to sort of learn as you just go, without having to have that sort of corpus of knowledge and custom code, like sort of the different responses that people might end up entering. But like on a high level, that's like sort of the model size. I think this definitely could be expanded better, even like greater. But I think Adi can also elaborate on his end for his model.
Yeah, so as you guys saw, like the model was nearing 1 million parameters. So I think in the future, definitely trying to reduce that model size. As for the training data itself, I think it was somewhere around 4,000 to 10,000 different samples that I collected, and then we tried to string those together to string an absolute diagnosis.
Amazing.
Thank you.
Yep. Any other questions?
Anything else?
I was just wondering, when you go into TKS, when you pick a focus, so let's say I picked artificial intelligence, do you get to also pick a specific strand in that, so like healthcare, or is it just general?
Yeah, it's actually very open-ended. I think like at the end of the day, yeah, you'll definitely see as you like, first of all, like congrats on getting in as well, and like super glad that you're joining the community as well. In terms of like the sort of focus process, you'll learn more about that like come September, but it's actually really self-guided. Like at the highest level, it's like you have a learn aspect. You just like learn a bunch of things and then congregate in like an article, and then you have like 2 replicates where you try to replicate a industry level project, or not even an industry level project, but like something that like is accessible or easily seen in the world, and trying to actually create content for that, trying to build videos, make videos, and then also like translate that into an actually functioning model. And then also the last piece of the puzzle is like a create. So those 4 elements is basically it, right? And then everything else that you learn is actually really self-guided, in the sense that you actually just build everything up on your own. You like end up like just like pairing up with a friend or whatnot, like trying to also talk to people in the community, and then sort of like source the congregate like the best information and knowledge and like sort of courses and whatnot. So it's actually really powerful, the extent that you're able to sort of create. The process works. That's what I'm saying.
Yeah. TKS gives you the toolbox, but how you use the tools and what you want to work on is entirely your choice.
Okay, thanks.
Happy to help. Cool. Amazing. Is there anything else from anyone at all?
Oh, do you learn how to code at TKS?
So this kind of goes back to what I was saying earlier, is that they don't explicitly teach anything, right? So what they'll do is that they'll give you a general direction that, hey, this is what you should be doing, and they'll give you the resources to do it, right? And I think the job as a student, which I think is probably one of the best parts about the program, is that you have the responsibility for connecting those 2 pieces of information together, right? And I think what's really beautiful about that is that it lets you develop the mastery and lets you 10x your own skills while having the resources necessary. Like, for example, if you, at least for me, like when I started TKS, I didn't really know too much about programming. So initially I was asking around, the community is amazing. I was asking around for like, okay, how can I like learn coding? There's a coding channel in our Slack as well. So you can always ask for help over there, and they'll give you really good resources as to how to, I guess, 10x your skills as I was talking about before. So I feel like because of that like community, you can learn pretty much anything, provided that you put in enough time and effort. And honestly, I think that that's probably the best part of the program.
Thanks.
Yeah, no problem.
Amazing. Perfect. Yeah, I completely agree. Cool. Sounds good. I think I just got a message from Kim and Harrison that we should be heading back now. So I guess like if there's any like 1 or 2 last questions, we can take those and then we can just hop right back over. Or any last comments?
So what do you plan to do when there are like more branches of medical health diagnosis? Because I noticed that you manually inputted like different keywords for the model to look out for. So what's going to happen when like there are more branches?
So if your question, oh, sorry.
Go ahead, Adi.
Okay.
Adi.
Yeah, so what I was saying is that I just correct me if I'm wrong, but I interpreted it as basically, if there are more diseases or symptoms, like how would you add those onto the model, if I'm correct?
Yeah, and if there are multiple, would you find a way for it to sort of make its own rules without having to manually input keywords for them?
So, okay, I think that's definitely something that can happen in the future, like where the AI just automatically abstracts different things and gets those keywords itself rather than you having to input it. I think as of now, like as for deploying that kind of thing on scale, I think one thing that's a problem with that is that you can potentially need multiple AIs for that, right? Like one to search for the keywords, then one to convert those keywords into like an actual diagnosis. So I definitely think that that's something amazing that could happen in the future. As of now, however, I'm not entire. I think there is some ongoing research in that kind of the field. I was reading a paper a couple of days ago on that. Yeah, so as of now, definitely a possibility, and I would really hope to do something like that in the future.
Amazing, cool. And then also like wrap it up really quickly. On my end, I think it's definitely about just like trying to congregate some of the best data sets and also like consulting with professionals. I think definitely like researchers actually at universities or like different like sort of institutions would actually have more sort of larger data sets that I can tap into, or like even just like pairing up with a few people to sort of create our own as well would definitely be amazing, or like a next step. So yeah, definitely agree with this one. Cool.
Yeah.
Sounds good.
Yeah, so if that's all, everyone just head back to the same gather link that we were at before, and we'll start a small networking session on the focus booth where you can learn about different topics. For example, if you want to go to AI, you can just go to that section. And yeah, thank you guys so much for coming, and I hope you guys had a fantastic experience.
Thank you so much.
Thanks very much.
Thank you.
Thank you.
Thank you. Thank you.
Thank you. Appreciate it.